So today's question is our example down here, figure 3.13, page 42. All right. So what we have is a square-based pyramid and a sphere, both resting on the horizontal plane. So they're both resting on the ground. Now we won't look at this for a minute. We'll just look at what we were given and our question box. Always read this so we know what we're working with. All right. They are in contact with each other. They want us to draw the plan and the elevation, and they want us to find the point of contact. And they're telling us how tall the pyramid is. The pyramid has an altitude of 58. So basically the pyramid is 58 millimeters up to the apex. All right, so here we have it here. We're able to pop this in here. To find its point of contact, it's not like when we had it on the cone. It's not like when it's resting on a cone where you can rotate it around. This is resting here on our flat surface. So we're going to do an auxiliary to find our point of contact. All right, here's our information. Just give ourselves a bit of room when we're doing our auxiliary because we're looking off. We need to look along our line here to get an edge view of it. All right, so an edge view of the surface in contact with our cylinder. All right, so we'll get that drawn in there. Giving ourselves a bit of room. So we have our X, Y line. So it doesn't tell us how much away, so we're just going to step down 10 millimeters and we're going to go 45. So that's what's telling us our pyramid is 45 degrees. It's 52 millimeters long. So 52 millimeters. 52 millimeters. Do the light lines for everything now before we kick off, and we can heavy in after. Alright, so we can heavy up. It shows in the question the circle or sphere is just coming in here. So we can heavy our surround. We'll dot up this. Actually, no, we'll leave it alone for now. Join our corners together. So this gives us our apex. I'm going to go straight on and I'm going to pop in my pyramid next before I pop in my sphere. Just because I know all my information for that. It tells us it's 58 millimeters tall. There it is there. It's the apex. And we're going to keep this light on this side. Alright. Because they overlap a bit there. So we'll keep that nice and light. So that's our pyramid, elevation and plan. Now we can pop in our go from there and we'll find our sphere. So it says there, it shows us we have a red line kicking out from the apex in plan to the bottom left, and it's on this here somewhere. All right, now don't actually know where it is, so we need to go and we need to get our auxiliary because we know the radius of it. It tells us it is 24. It tells us it's here somewhere, but we can't actually pick exactly where it is. We don't know where its center point is. So therefore we need to actually get an auxiliary to look at this. So that's perfect. We have our surface. We're going to get an edge view of this portion here. We're going to get an edge view of that. So if we look in at the edge, we get it as an angle, and then we'll be able to see just exactly where our sphere connects. So look along the line. So we're looking along, it's flat here. This here is its true length because it's level in another view. So if you look along something that's a true length, you get it as a point and you get it as an edge view. So we'll bring all our points up. This is our x2, y2. We know our height of our apex. It's the same as our elevation because we are creating an auxiliary elevation. Alright, so this is our elevation. This is our plan. Now I probably have left this too close, to be honest with you. Just I'd say it'll overlap it by mistake, but we should be staying going with anyway. And this is our auxiliary. So the reason it's an auxiliary elevation is it's brought from the plan. Okay, so we can heavy this in because we're standing here looking in. We can see all of this object even with the sphere there. So we can heavy this in here. And what we're just looking at is this triangle basically. But that's giving us edge views of these two surfaces. Now, moving on from here, it tells us our radius of our circle is up 24. So nice and handy, we just step up 24 off the ground because the sphere makes a tangent to the baseline. Alright, so sphere has the baseline, the xy line and tangent to it. So you can literally step away the radius and do a light line. Alright, now if you want, you can do it two ways. Alright, you can bisect the angle, bring it up to hit off it. That'll give you that as well. Or you can actually step out from our edge here. You can step out 24 millimeters, go parallel to it where they cross over. So there's two ways. Now, I'll just do it the way they have it in the book as well, so you can see exactly what's going on. But there's two ways. You can step up and step out, or we can bisect our angle to make it hit. Either or is absolutely fine. So we'll go with their method anyway. We'll do our book's method, I should say. We'll do our arc, so swing an arc to bisect the angle, or swing an arc. Make it a little bit there. There we go. You want to create two further arcs from where this one hits off the edge of the pyramid and the ground. That gives us this. X, joint corner to this. Stepping out where they hit here. That is your sphere. So like I was saying, there's two ways of doing this to get that, alright? You can step out 24 from it, bring it down to hit our level line or parallel line to the XY line, or you can just bisect it like they have, alright? Now, here we have this. Now we need to find its point of contact. So the point of contact is basically, we're going to go 90 degrees perpendicular off the edge of our surface through the center point. So get one of your set squares. And here we have it here. We're going to get this edge view. I'm going to step it back a little bit just to give yourself a bit of room. We get our 90 degrees. And we're going to slide it up. Oh, after slipping there. Back again. So I'm going to use my 2 as I usually do. This is our constant over here. It's not moving anymore. Now we've got my center point. I'll bring it back to hit there. So where I've hit here, this area here, that is my POC, my point of contact. So there we have our point of contact. All right. So we're going to bring our point of contact back down, and we're going to bring it down parallel to our edge surface. There it is there. Bring that down. And it's going to stop along this line here, okay? Because this is nearly like our extreme of this. So when we look in from here, this is our extreme generators, our extreme outside our diameter of the circle, our sphere. So we're going to catch it here. So that'll be where our point of contact is there. That there's our POC, point of contact. Now we'll bring down our center point of our circle. There it is there. So that is our center point. Compass should already be set with this radius. You don't need to change it, just leave it set. Alright, so there we have it now in our plan view. We have our center point. We can transfer that now up. So we can transfer that up into elevation. So we're not going to do a point of contact just yet. We're just doing our circle. We have our height because it's the same as the radius. So get your compass, just step up to 24. Here we have it there. It rests on the horizontal plane, meaning it rests on the XY line. So what we can do now is we can pop in our heavy and our dotted lines. Same with down here, our heavy and our dotted. And that is that. Now, last but not least, our point of contact. So I'll go back to my pen here. And I'm going to send it up. Now we don't know, just from using this and this, we don't know the height of it. But we have information over here, because this is an auxiliary elevation. So therefore everything height-wise that's in this view is the same height as this elevation, because that's the common denominator there of both elevations. So heights up here match the heights over here. So we can actually pick our height there. So get your compass, steel bit on the XY and X1, Y1, even though I call it X2, Y2. Step it out to our point of contact. There it is there, so get it on my compass. Bring it back over to our XY line. Swing our arc. Where crosses that pink line there. That there is our POC, our point of contact. Alright, so that is the question there, page, what are we on? 42, figure 3.13. Alright, okay.